Hey guys, welcome to my tutorial for smart contract development on the Neo platform. In this tutorial we're going to take a dive into how to develop a smart contract for the Neo platform in C# using various features of the Neo contract framework. And we're going to discuss some of the various considerations and nuances involved when it comes to smart contract development. Now this tutorial isn't an absolute beginner course and it assumes you've got some basic knowledge and experience on Neo smart contract development. So in fact it's a logical progression on from the guides on the internet for how to set up a local development environment, how to spin up a private Neo chain on your local machine, and how to write your first Hello World smart contracts. So if you've done those, then this is a great place to continue. If you haven't done those, then I'll put a link below and you can get started there, and then you can come back here when you're ready. Now this tutorial is going to be focused on developing in C#, which is one of the main preferred languages for the Neo smart contract framework. I've chosen C# because as a Java developer, it's not too hard for me to get a grasp on the syntax, and it has all the features and APIs available, unlike some of the other languages are still in development and don't have all features available yet that say C# or Python does, so just be careful with that. As long as you've got some knowledge on object-oriented programming languages like Java, then picking up syntax for C# is quite easy, I've found. So the smart contract we're going to be focusing on during this tutorial is one that I've mocked up here, purely just to show you some of these concepts to you. So functionally, the smart contract is a claims submitting and approval program for a workforce. So an employee submits an expense claim which gets sent to the smart contract. There's some logic in the smart contract that says if the claim amount is less than a certain threshold to automatically approve it. Then an accounts manager can also interact with the smart contract, and for a given expense claim they can either approve or deny it. So it's just a simple example, but it allows you to see some good examples of some of the concepts, APIs, features and limitations of Neo smart contracts, how to interact with them and how they interact with the Neo platform. So this is a smart contract here in my Visual Studio project. I'll link the source below so you can create it yourself if you want to mess around with it. I've also got I've spun up a local instance of the Neo platform, and I've got the Neo GUI running here where I can deploy and invoke my smart contract. But for the purposes of this tutorial, I'm actually going to execute and step through the contract using what's called the Neo debugger. So that's this thing here. Basically, this is a set of tools from the City of Zion which allows you to debug Neo smart contracts, and you can literally step through them line by line during execution to help diagnose issues. So this is very helpful and allows you to speed up development and identify errors and issues. So I highly recommend you check it out if you haven't already. I'll include a link below. I've actually set up my project in Visual Studio so that I can, when I build it and I can run it from here, it will automatically use the Neo debugger and bring up the smart contract there ready to be executed. So just take note that the debugger is still a work in progress and doesn't have all the features of a proper Neo instance. So some syscalls and APIs aren't supported yet. So if you're trying to do something that fails and the documentation says it's not supported, you may run into issues and you may need to comment it out and put it back in when you're executing it on your proper local Neo platform. So, but for now we're going to stick to the debugger because it's great for learning, and that's what we're doing today. So before we go into the code, I just want to make a couple general comments about Neo smart contract development in C#. So due to the architecture and implementation of the Neo VM, not all C# features and libraries can be put into your smart contracts. In fact, you'll find that most of them can't be used. This is because the Neo VM and smart contracts in general, they need to be very lean with the intention of quick operations, small memory, small storage, anything complicated, big libraries can't be used. That should be done outside the smart contract with the results then shared with the smart contract. So for example, you can't just do a REST web service call from within a smart contract to some web service out there. So those libraries can't be used. So what you do is you do the web service call in a program or app outside of the smart contract, outside of Neo, and then you'd use the Neo APIs to then pass the results into the smart contract using an oracle or something like that. So you'd program your smart contract to accept results of the web service call and then proceed with logic based on the result. So there's various other important limitations to know. Things like exception handling, floating point data, they're not supported yet. So I'll put a link below to the Neo documentation, which delves into some of these limitations in more detail if you want. And one last thing, just be aware of gas. Many operations in invocations in a smart contract cost gas. So you just be aware of this and try to keep anything that's not free to a minimum where possible. I'll include a link to the system fees below if you want more detail on that one. Okay, so let's take a look at this contract now. So the first thing to note is we've got a class with one class with everything in it, which includes a main method here at the top. So as a general guide, your entry point to the smart contract should always be a main method. And you should always have one return type and a consistent set of input arguments for all scenarios in the smart contract. So what this means is if you have something like a list of arguments of various types, like this contract, you need to make sure that the arguments list passed in matches the order and type of the way that they're parsed and processed in the smart contract. So in this smart contract, we have our main method, and the main method ends up calling one of two other functions in the smart contract. We have a create claim function here, returns a Boolean, and a process claim function here that returns a Boolean. So apart from those two functions, what else have we got here? We've got a static byte array here that stores the contract owner hash. We'll go through that in more detail. We've got a constant here, which is the expense threshold, $15. And we've got a C# struct here, which represents a claim. So the expense claim contains an employee ID, claim date, claim amount, status, claim ID, and an approval timestamp. We'll go into these in more detail soon. So back to our entry point though here, the first parameter is a string which defines the operation, create claim or process claim, and then a list of arguments which what they are will depend on what the operation is. So this pattern of string, operation, and array of objects here, it seems to be quite a common approach for Neo smart contract development from what I've seen, and it makes sense because normally there's more than one scenario you're going to need to do in the smart contract, and for each scenario you're going to have potentially different number of arguments basically. So the first thing that the smart contract does is it does a check against this thing here, which is a runtime trigger. So depending on whether it's a verification trigger or an application trigger, it will execute different logic in the main method here. So what does this mean? Basically, a smart contract can be triggered via different means or methods. So there's actually 4, but this smart contract we're just going to talk about the 2 more popular ones. So a verification contract is used to call the contract as a verification function, which can accept multiple parameters, and it should return a Boolean indicating success or failure. So what this means is when you're transferring assets from one account to another, the verification trigger part of the contract is going to be executed to say whether or not that transaction is valid or not. So in this case, we should ultimately have logic that returns true if the transaction should be allowed to execute successfully, or false if it shouldn't. Whereas an application trigger down here, it's used to call the contract in a more traditional sense via direct invocation, for example. So the execution of the contract was invoked directly, and we have the input parameters, we have the output, and we're going to use those to go through, determine the resulting state of the contract and its output. Now, this smart contract doesn't actually involve any transfer of assets yet, that'll be the next video. So this verification trigger part of the contract won't actually get executed, but I included it so I could explain the concept to you. So in our next guide, we'll expand on this concept and show an example of the verification trigger in use. So in our contract, we're always going to be dealing with this part of the main method, which is the application trigger part. And the rest of the main method here is pretty simple. It checks what the operation parameter is here, and depending on which one of the two functions it is, it's going to call the other function in the smart contract, passing in the parameters. For each operation, it also validates the list of arguments to make sure that they're all there. And if not, it'll raise an error and exit. So this leads me to another important point actually. Because smart contracts are self-executing digital agreements, they need to be airtight in terms of validations. So this means that you need to make sure every input is validated properly. We need to make 100% sure that the contract won't crash or fail as a result of bad or invalid inputs. So this point is enforced here on the string operation parameter. We have a default case here which says if it's not one of those two, we're going to raise an error and exit. Okay, so let's take a look at the create claims function now. So this function takes three parameters, as you can see here: claim date, employee ID, and claim amount. So what we're going to do with this data is we're going to create a new instance of our claim struct that I showed you before, and we're going to populate the fields that were passed in. So because it's a new claim, we're going to set the status to pending here, and the claim ID wasn't passed in, but it's actually a generated or derived value based on the claim date and employee ID. So these operations here are purely for string concatenation to get our final build-up string of claim date and employee ID together. So an employee can submit only one claim per day, therefore making the generated ID unique. You'll see why this is important soon. So once we've built up the claim ID, the first thing we need to do is make sure it doesn't exist. So the way we do this is by querying the persistent store to see if the claim ID exists or not. If we find it already exists, then an error is thrown and smart contract exits, because we can't create a claim that has the same ID as an existing one. Otherwise, the next thing that we do is we compare the claim amount to the static threshold value. If it's below the threshold, it automatically sets the status of the claim to approved. Otherwise, it leaves it as pending. So the final thing that that this function does is it stores the claim on the persistent store. So the way the persistent store works is it can store a string or a byte array based on a given key, which can be a string or a byte array as well, as the ID for that. So it's a key value relationship. So to get back or delete what you've stored, you need to provide the key that was used to store it. So think of it as like a postal address when you're putting stuff in storage, or a locker number. So when you store it, you have a locker number, and then when you want to get it back, you need to provide that locker number. So and they need to be unique. So I actually wanted to store the struct itself in the persistent store. However, to do that requires serialization, deserialization, and that's not fully implemented in Neo yet, but I believe it's coming soon. So once this comes, it'll allow you to store the struct in the storage using just one key, not having to split it out like we have here in a clever way. So that's really it for the create claim function. Once it's done, it writes out to the log and returns true. So let's see this one in action now in our Neo debugger. So what we'll do is let's try create a claim with that as the claim date and HPAP as the employee and claim amount of 10. So we can step through, we go into our main method. It's not a verification trigger type, it's an application one. Our operation is create claim, so we call our create claim function passing parameters. We create an instance of our struct and we set all the values. We build up our claim ID string. We check to see if that claim ID already exists, and it doesn't. Now we compare the claim amount to the threshold. It's less than the threshold, so we're going to approve the claim, and now we're going to store the claim into storage and return success. Cool, so that's all good. So why don't we try to do that again and see what happens with exactly the same values. So because we're creating the same claim again, it's going to have the same claim ID. I actually expect it to fail when it searches for a duplicate. So here, it searches for that claim ID, and yep, it's found it. So it's saying you can't create this claim, there's already one in storage, and exit. So what we'll do is we'll create one more with a different threshold and a unique key. And we expect it to be created successfully, but not to be automatically approved this time. So let's have a look. Yep, it didn't go to be automatically approved. Cool. So now that we've successfully created a claim, let's take a look at the process claim function. Now, I'm not sure if you noticed before or not, but there was a bit of code commented out in the main function before the process claim function gets called. This bit of code here calls a function called checkWitness, and it passes in the variable that we defined at the top of the class. So what this does here is it takes in a passed in hash and it checks to see if that is the owner of the contract or not. So essentially it's saying, I need to check if the person currently running me is the contract owner, and if it is, then we'll do something, otherwise we might not. So because in some instances we only want the contract owner to be doing certain functions. So in this case it's processing a claim, but it could be other things like, for example, refunding an ICO. So the reason it's commented out here is because, like I said before, I'm showing you this contract on the Neo debugger, and it doesn't have all the features yet to mimic a contract belonging to a particular script hash. So this part of the code is for when I execute the contract on my local Neo instance. But for this execution and tutorial, I'm going to leave it commented out, and we'll assume that it is the contract owner executing this function. So the parameters for this function are the claim ID and whether it's approved or not, which needs to be a Y or an N. So, and like our create claim function, it returns a Boolean. So here's the body of the function. The first thing we do is take the provided claim ID and we query the persistent store to see if it exists or not. So unlike before, in this case, if it does exist, if it doesn't exist, we raise an error. If it does exist, then that's good. So the next thing we do is we get the status from the persistent store, and we check to see if it's not in pending status, because we don't want to approve or reject a claim that's already been processed. So that's what this part of the code does. And once we've passed that, we have a valid claim in a valid status. The next thing we do is check whether we need to approve it or not based on the provided parameter. So if the parameter is n, it doesn't get approved, we update the status to rejected and persist that back to store. If it is approved, then we update the status to approved. Another thing we do though is, you might have noticed there's an approval timestamp variable in the struct which wasn't set before. So once it gets approved, what we do is we call these blockchain functions here to get the timestamp, the Unix timestamp, and we set that to the parameter approval timestamp. So basically, when it comes to timestamps in Neo and blockchains in general, the way to figure out when now is in a smart contract, you need to get the timestamp of the previous block on the Neo blockchain, because that's the only way all nodes can agree on what now actually means. So once we've got that, we push everything back to the persistent store, we log a success message, and we exit. If the input parameter wasn't while end, then we log an error message and exit false. So that's the process claim function. So let's see it in action now. So what we'll do is we'll try to approve one of the claims we created earlier. So let's bring up our debugger and we reset it. So now we're going to process a claim, and we're going to try process this one, and we should go into our process claim function, check to see if it exists. It doesn't exist. It's in pending status, which is good, and it's going to be approved. So we get the timestamp, update it to approved, set the timestamp, log a happy message, and exit successfully. Cool. So now let's test one of the other validations. Let's try process a claim which doesn't exist at all and see what happens. So that 99 one we haven't created. So I expect it to get it, check to see if the claim exists, and find that it doesn't exist. And yep, claim not found. So we get the error message logged and we exit. Cool. So that's it really. We've walked through the entire contract now, so hopefully you've taken away some new things here, and to take into consideration when developing Neo smart contracts. Hopefully you've got some new concepts and a better awareness of what you can and can't do. So in summary, we've shown or demonstrated the following: how to structure your smart contract using a main method which calls other functions, how to correctly specify input and output parameters and the best practices for dealing with them and validating them, how a smart contract has different trigger points and how we can use them to determine which logic to execute, how to query the persistent store, how to create a struct and push it to the smart contract persistent store despite despite serialization and deserialization not being supported yet, basic operations and logic on numbers and strings in smart contracts, what the checkWitness function does and why a smart contract would need to use it, and using Neo blockchain to obtain a timestamp. So that's all we have for you today. In our next video, we'll take the next step forward in smart contract development using our claim example here, and we'll build on it, and we'll delve into other topics like calling smart contracts from other smart contracts, dealing with assets, and interacting with a smart contract from outside the Neo platform using provided APIs. Thanks for watching, guys.